Hello and welcome to part 3 of my AGK FPS tutorial. It's been a while. I was hoping to add a few more things in, but I just haven't had time. I've been very busy with other things. And I've had FPS Creator Reloaded for a start. I've been playing with that a lot, and I do enjoy that. It doesn't strain the brain. It's nice and easy. But I thought, I'll come with this. I've had this done for months. So I thought I might as well get it done and at least show you how to get collision on your models, and then you're away, you've got a movement, you've got collision, and you can start playing around with whatever you're thinking of doing. So yeah, this is the collision code, as you can see. It's relatively simple in its premise. It's maths collision, which I've used for a lot of my projects. I mean, when Dark Basic came out, the original collision commands, they worked, but they were slow. They were so slow. And this is something I worked out. I did it the physically manual way at first, just by actually putting the coordinates of exactly where I put it in and working it out that way. But it's progressed to a system like this where you can use it with any object, just working from the object properties. So basically, yeah, here we go. You have to go through all the buildings. That is one problem. You could possibly limit it by distance, but even then you've probably got to go through the buildings to check the distance. So I'm not sure how you could get around that easily, but it still runs pretty well. It's not that slow. It's certainly faster than using inbuilt collision in a lot of instances. So basically, you're checking each edge of the object. There's 4 obviously edges. It's not detecting up and down, it's just detecting movements forward, backward, left, right, that sort of thing. You could add other collision in. It's the same principle. You just have to use the Y direction rather than just the X and Z. But yeah, basically checking here, object X player, so that's you, that's your X position, and you check it against the building's X position. So if it's greater than the building's X, which will be in the center of the building as standard, minus building info n,1, which is the size, I've put it there, you can see it's the width of the building, divided by 2, because you've got to remember your position is from the center, your building's position is from its center, so it's going to be half the width. And then minus 2. That's just to stop you from basically being able to walk into the building and see through the building. It's just, just puts it back a little bit further so that it just looks as if you're pushing against the building rather in it. So yeah, if that's true, so if it is greater than that X minus that, then it'll go to the next line and that checks the opposite side. So you're going to say if it's less than X and it's, well, yeah, basically if your player object X is less than the building X minus the width, again divided by 2, it'll go to the next part, and that's where you check your Z, which is the forward and backward motion. And it's all pretty similar. I mean, the first line that I've explained is basically the same for every single one. You're always checking against the width or the depth of the building. The height is, like I say, it's not used. It's there. You could use it if you needed to. Say you had some steps you wanted to be able to jump on, then you'd have to do that. And once it's determined that you are within all these parameters, then ignore all this lot. The colloid, that's just something I tried, didn't work. You basically just set the object position of the player back a bit. So you get the position of the player and the building. You then just minus 2 of it. It's simple as that. So set object position player, get object X building N, minus the width divided by 2, minus 2. That just basically sets it back to the position it's found it from. Simple as that, and it'll just give you collision. So as soon as it finds that you are greater than that X, less than that X, and obviously greater than the Z and less than that Z, then you will run this code and it'll just replonk your player at the position where it's stated. And you do the same for each side, and that will give you collision. Simple and fast. That's the main thing. I'll run it. It's not very good on this capture, but we'll run it. You've seen it before. And basically, there's the building, and it works. Slides. It just basically puts you back. You go there, and as soon as it tries to go beyond that, it just pushes you back to it. You can't tell. You can if you go mad. I mean, I've used -2. If you try to start going mad with those, you will get it sort of jumping and stittering, but you've got to basically get it to jump back to exactly the same position to check from, and you're fine. You've got collision. So yeah, a very short one this time, but I thought I'd get it finished for anyone who's watched part 1 and part 2 and are thinking, cripes, where's part 3? I want to know how to get it to collide with stuff. And it works pretty much out the box with any object you've loaded, any size. Obviously it's got to have 4 sides. It's not going to work with an object that's awkward, so like that shape there. If that was 1 object, it wouldn't work, but as it's 2 objects, it should work still. So let's see. You might get a bit of glitches occasionally, but bop. There we go, we're stuck. Yeah, so it works fine with just basic objects with 4 sides, but you can advance it. You can add more collision in. You can make it work with all sorts of shapes objects if you want. That's just the basic idea. The basic idea is you check your coordinates against the building's coordinates minus half of its width or depth, and that will get you the exact position to place your collision points. And there you go. So right, let's escape that, and there you go. I'll just scroll down the rest of the code in case you just want to copy it and not think about it. There you go. That's the extra code. Copy that in, and you'll have collision on your system. I'm hoping I've explained it well. It's difficult to explain perfectly. Well, I think it is anyway. But yeah, it's fairly simple. It's just checking your position against the building's position, and it's working out what actual width, because obviously you're using the X and Y coordinates, or X and Z I should say, sorry, X and Z coordinates to position it, and then you need to know what the size of the building is so you can push it back and check against the actual edges of the building rather than the central point of the building. So that's what all this is doing. Building info, like I say, that's the width, and you've got the depth as well, and if you wanted to you could put height in and it would do pretty much the same. You need a jump for that, of course, and I haven't put a jump in, but a jump isn't that hard to work out, I'm pretty certain. And you never know, I might continue and go further with this and add some more stuff in. I might even try and put some sort of, I don't know, be boxes, it won't be people, boxes that run around and shoot you, but yeah, probably not, unless there's a major call for it, which I doubt. So yeah, until next time, have a nice new year, and I'll catch you later.